Alright chemists, so now we're going to get into chemical reactions and basically the 6 simple generalized chemical reactions, and you should be able to break down most chemical reactions that we deal with into one of these 6 generalized chemical reactions. Now we're going to deal with some more specific types that you'll just need to know. But right now these are the 6 basic generalized, and we start off with a synthesis reaction, decomposition reactions, displacement reactions, both single and double, combustion reaction, which is exactly what it sounds like, and an acid-base reaction, which again is exactly what it sounds like. So alright, so a synthesis reaction. Two or more simple components, they can be elements or compounds, combine to form a more complicated component. And generally, so it's generalized equations, you'll have this formula: A plus B leads to AB. Okay, and here we have iron and sulfur combined to give you iron 2 sulfide. Alright, and you'll see that as usual all of our reactions are balanced. Then you have a decomposition reaction. So this is where a complex molecule, doesn't have to be super complex, just more than one or two things, more than one thing. A complex molecule breaks down into simpler compounds or elements, and we see that. So the generalized equation again is AB goes to A plus B. So water here can be broken down through hydrolysis to hydrogen gas and oxygen gas. Oh, just quickly, just about the word hydrolysis, which is hydrolysis. Lysis means to split apart. So if you ever see the word lysis at the end of something, that means to split it apart. Displacement reactions. So we've got 2 types. We've got the single and the double. Alright. So when one element or ion trades places with another, here we have A plus BC goes to AC and B. So here you can see how the 2 have switched places. One example which we'll see is, again, a simple equation we need to know later on for a metal plus an acid, but is magnesium plus hydrochloric acid gives us magnesium chloride, the salt, so a metal and a non-metal, that's a salt, and hydrogen gas. The double one is where we have anions, which are the negative ions, and cations. Now, some people say cations, cations. I prefer cations because it's that way you're pronouncing the ion part. So cations, we've got the positive ions here, that's a cation. So the anions and the cations of 2 different molecules swap places. So it's AB plus CD goes to AD plus CB. The example is lead nitrate and potassium iodide. You put those together and that ends up giving us lead iodide, so PB is lead iodide and potassium nitrate. Alright, we're almost at the end. Which brings us to our 2, I'll scrub that a bit there, our 2 slightly more specific reactions. So we've got an acid-base reaction. Now an acid-base reaction is a special type of double displacement. It's also known as a neutralization reaction, and we'll see why in a second. So the hydrogen ion and the hydroxide ion, they react together to form water. Okay, the other ion give a salt, so an ionic salt, so a metal plus a non-metal put together, and it has this formula. So the generalized equation is HA, that's just the ion, B, again that's the other ion, OH, go to give us water plus the salt. Now see here how that's at the front, that means that's a metal, okay, and that means that is a non-metal. So when we put those together, they switch around. That's all that happened there. So acid plus a base gives us a salt plus water. That's the generalized word equation. Hydrochloric acid plus sodium hydroxide gives us sodium chloride. That's salt. I mean, that's table salt, plus water. All right. So the combustion reaction. That's what that says. Before my clumsy thumb rubbed that out, is where a compound or an element reacts with oxygen, or it oxidizes. So that's what we call it. Pretty oxygen. It's oxidized. So a compound reacts or element reacts with oxygen to give a new product plus heat. That's one of the identifying factors there. If it's a carbon compound, it usually gives carbon dioxide. If it goes to completion, which means it burns everything, it usually goes to carbon dioxide plus water as a product and heat. So here's the burning of methane in oxygen, gives us carbon dioxide plus water plus heat. Now, here's hydrogen gas being added to oxygen. Okay, so it's being combusted in oxygen. This gives us water plus heat. Now, you'll see this if you light hydrogen gas in the atmosphere, it will explode, and that is you producing essentially water vapor, but it's a steam, so it goes up into the air, and heat. Now, there's always the fun conspiracy theory that, Shell or whatever big oil company you like has a car that runs on water. But the thing is, they can't, because water is a product of combustion, which means you can't combust it any further. It is a product of combustion. Alright, that's it. Know those, make sure you can study them, and make sure you can, we'll have a few more tips on the website, but make sure you can find, every time you get an equation, you can sit there and you can break it down into one of those 6 types of equations. Alright, good work.